Here you see the gap generators as they currently look in March of 2015. I've asked myself over and over, how can I best group these together to produce more power and for ease of mass producing? Well, my mind goes way back in history, all the way back to 1862, the Gatling gun. Let's look at some photos of the Gatling gun. Here, no doubt, is a modern version. Here is what I propose, the gap generator Gatling gun style. These are just two-dimensional drawings, but I think you'll get the point. Here is a front and side view of what I propose. On the right is the front view showing 6 coils in the same configuration as the barrels of a Gatling gun. In the center is a hole which goes through the entire length. This is for a bearing and rod which holds the piston, which travels back and forth between 2 sets of the coils and magnets. On the left is a side view of the coils. In this section is where the magnets are located, 3 in each of the 6 pockets. Here's what 2 of these sections look like when assembled. Resembles the 2-cylinder model, but this style has 6 coils and 18 magnets on each side. The magnets on the current gap generators are 1 inch long and 3 inches in diameter, 3 attached to the core of each coil. Now I'm sure a 3-inch long by 3-inch diameter can be used. The part in the middle is the piston. The magnet configuration is different. 1 3-inch diameter by 1 inch long here in the midsection. 1 2-inch diameter by 1 inch long here in this section. And another 2-inch diameter by 1 inch long in this section. The same thing in all 6 areas of the piston. In the gap power update of 02/28/2015, I describe how I believe the gap generator operates and why I feel that way. For those that haven't watched the video, I'm inserting a portion of it here. Today's date is February the 28th, 2015. And I feel it's time for me to add some information to the Gap Power website. Information that I've had for over a year. This information is about how I personally believe the gap generator works and just exactly what it is. It has taken me a long time to figure this out, but it takes me back to what I thought was happening at the very beginning. One thing I've discovered about oscilloscopes is that when they're set to check DC, they include any and all AC in the circuit. But when they're set to AC mode, they reject all DC and check AC only. When one sees the 36-volt bank of batteries under this device, it's natural to think it operates on DC, but in fact, it operates on AC. Now for what it is and how it operates. The first thing is, just like a simple and basic inverter, it converts the DC current of the batteries to what is called extra low voltage AC, which is voltage less than 50 volts RMS. So the first thing the gap generator does is convert the DC to AC, which makes it a very simple and basic inverter. First, I'm going to give the output power if I were measuring both input and output in DC prior to the update of 02/28/2015. Let's look at an animation of the Gatling gun style in operation. Where it now has 2 cylinders, one on each side, it would have 12 cylinders, 6 on each side. This would no doubt produce much more power. The 2-cylinder produces 32.065 watts over unity per cylinder. Multiply that times 12 and that would be 384.78 watts over unity. With better bearings to reduce magnetic friction, it may produce more. Now, let's expand it a little more. See how simple it is to make this a 24-cylinder? I believe this would produce a minimum of 769.56 watts of power. That's more than enough to operate an average size home. And get this, this thing is only 12 1/2 inches wide and 31.23 inches long. Place 2 of these side by side and produce 1,539.12 watts. Now this is getting into some serious output, all in an area no larger than 30 inches by 31.232 inches. Batteries could be stored underneath just like on the 1 and 2 cylinder models. Let's look at the middle section and I'll describe what I did there. I added a 1-inch thick plate to the magnet holder, which allows 12 more coils to be attached, utilizing the magnets already in that section, eliminating some of the cost in manufacturing. Now for the output of over unity power by checking in AC RMS, as I did in the gap power update of 02/28/2015. It's very simple to figure. Each coil produced 145.7 watts over unity. So just multiply the number of coils or cylinders by 145.7 to get the watts over unity produced by the gap generator. Now a 12-cylinder one-stage would produce 1,748.4 watts. A 24-cylinder one-stage would produce 3,496.8 watts. A 24-cylinder two-stage would produce 6,993.6 watts. If I'm correct in my thinking that AC RMS is the proper way to measure input and output power, one 12-cylinder one-stage is all that would be needed for an average size home. The gap generator may not need the rotary portion. I'd like to see it tested using a shock absorber at each end of the piston rod, which runs through the center of the coils and magnets. keeping everything on center line. This could shorten the travel distance to 1 inch. It's now 2, and could increase cycle time quite a bit. They could be manufactured in different sizes or models. A 1-stage 12-cylinder, a 2-stage 12-cylinder, which would be 2 independent 12-cylinder models placed on the same platform, a 1-stage 24-cylinder, a 2-stage 24-cylinder, which would consist of 2 independent 24 cylinders placed on the same platform. If more power is required, just keep adding another stage, and so on. As I stated in an earlier video, I'm not going to be spending any more money on this project, but my mind does continue thinking of ways to improve it. I thought this would be some good information to pass along. Thanks very much for watching. Manufacturing and sales recommendations. Now the following is nothing more than a few suggestions. Let's start with manufacturing. Manufacture most component parts by casting aluminum. Another option would be to use powdered metal technology. Any metal item with straight up and down or straight through design is perfect for this manufacturing process. Most items that make up the gap generator fall into this category. There are several powdered metal technology businesses in the eastern United States, or set up that process in-house. Except where iron or steel is a must, use aluminum. This is due to the magnetism. I'm sure there are other strong non-metallic materials that could be used. The magnets are made using the powdered metal technology, and there's a lot of them in the gap generator, and they're very expensive. Tight tolerances can be held with powdered metal. I've worked with it in the past. Use Control Technology Corporation programmable controllers. Throughout my business career, this is what I used when making automated machinery for in-house use. Unless another brand was specified, Control Tech was used for automated machinery produced for customers also. If not the best, Control Tech would rate near the top of the list. Their programming is very powerful, straightforward, and simple. Design and build automated or semi-automated assembly equipment. For inserting magnets into the magnet holders, I suggest a clamping device attached to a worm screw operated by hand. The magnets are very powerful and very dangerous to handle. Have a regular assembly line process, kind of like the automotive industry. Henry Ford had a good idea. Why not use it? Now for sales. Set up a distributorship. This could be worldwide. What is a distributorship? It's a franchise granted by a manufacturer or a company to market its goods in a particular area. Which to use, batteries or supercapacitors? Well, I don't know too much about supercapacitors, so I can only pass along information I've read. Advantages. Number one, they have an unlimited cycle life. As compared to batteries, they're not subject to the wear and tear of aging. And number two, they don't require a full charge circuit. Number three, quick charging times. And number four, cost-effective storage. Now for their disadvantages. Number one, energy density. They hold only 10 to 20% of a battery. Number two, low voltage cells. When more than three are connected in series, the circuit needs a voltage balancing element. And number three, high self-discharge rate compared to batteries. Now for the batteries. The gap generator needs to be under load while operating. If not, fuses or relays will blow. Sometimes both. To prevent this from happening, I propose monitoring the state of charge to keep it within the green section of this chart, maybe into the low 90s. This would ensure long battery life with no damage to the gap generator. This should be very easy to do. In today's world, this technology is in use constantly. 10 6-volt batteries in series with a 36-volt section in the center used to operate the gap generator. The left coil would charge this 30-volt section of the battery bank, and the right coil would charge this 30-volt section. These two lines are from the middle 36-volt bank to operate the gap generator. The positive line attached to the batteries here, and the negative line attached here. I've operated the gap generator with a setup like this. I've also charged a 30-volt portion of a 60-volt bank of batteries. They were not attached to the gap generator. I feel the only thing lacking is the electronic device to monitor and control the charging of the batteries. Electricity used by a home or whatever would come directly from the batteries. Actually, the primary use of the gap generator would be to charge the batteries on an as-needed basis. It would turn on and off when necessary. I've tried to demonstrate this in a simple way by using the 60-volt battery bank. I'm sure this could be done by using a 36-volt bank of batteries.